And that brings us right to animal behavior, because animal behavior is a complex system, okay? Animals interacting in nature, finding food, moving around, living in a forest, in the oceans, whatever. What they're doing is very complex, and they create fractal patterns, okay? And so the idea came about that we can use those ideas from physics, from fractal geometry, mathematics, and apply it to studies of animals, all right? And Konrad Lorenz is he's the founder of the study of animal behavior, all right? And he recognized early on that the condition of the animal is very important for how it behaves, okay? Now, don't worry too much about the graphs, but I wanted to highlight to start this that for about a decade, last 10 years, ecologists started to recognize that those animal behavior patterns, movement patterns, are very complex. And they happen with fractal geometry, okay? So it means that if you take how far you move most of the time, it's not that far. But sometimes you move very far. I moved all the way from Canada to Japan. But here, I only move sometimes between Kyoto and Aichi, or between my house and my office. So the more variable it is, the more complex it is. And it turns out that in nature, animals have this very complex kind of pattern of movement, all right? And so if you remember the Pollock paintings, this is not complex, just a line, and this is not complex, just a square, but everything in between is complex, okay? To some level. This is if an animal moves randomly with no pattern, it looks like this. But if an animal moves with chaos, it manages to go to many more places to explore, all right? So that has become important. So this is an actual animal movement track. That's a black-browed albatross. They're a seabird. They forage over the Pacific Oceans. And this is a total track. The small version is here, okay, and it looks similar. And then there's a small version over here. It looks similar. Scale-free, it's fractal. Every scale has the same pattern, all right? And it turns out that when albatrosses are trying to catch food in a very complex environment, where the fish are over here and over here and over here and far away over there, then their pattern looks fractal like this. But if they're catching food when all of the fish are everywhere, just random around the ocean, the area, they don't need to be fractal. They can use a much simpler form of movement, okay? So animals need to be able to change their behavior depending on the environment, all right? From complex to simple. And so to change track, I want to highlight the 2 points from this. The first one is that fractal patterns, they're flexible, okay? A heart beating, if it's in chaos mode, it can adapt to the changing environment. If it's in static mode, it cannot adapt, okay? Same for an animal. If it's in chaos, it can change its behavior easily and regularly to meet the condition. If it's not in chaos, maybe it cannot, okay? So that's error tolerance, the first one. And the second one is, as I just said, complicated search patterns tend to be fractal. It might help animals to find resources more efficiently or better, okay, than simple search patterns. Okay.